Mr. Crispin here once again, and welcome to my workshop. I just can't quite see what's going on. Let me try and get a little closer, just a little. That's the last time I put my moustache near any rotating machinery. Now, why do I have a lathe and a milling machine? So that I can make parts for my lathe and milling machine. Now, today's video runs very much along those lines. I require for my upcoming locomotive components the use of a Coventry die head, what the Americans might call a geometric die head, and I want to mount this on my Myford lathe. Here at the Myford Tailstock, you can see what I'm trying to achieve. The die head needs to sit in front, in line with the tailstock, and as it happens, the diameter of this and the diameter of my tailstock quill are within 10 microns, less than half a thou of each other. So with that said, I've had a bit of a vision of what could happen here, and we will kick off with some machining. Following my vision, I have sat down at the kitchen table and jotted some dimensions down on the back of Boccherini's Minuet in F, and following that I have knocked up a diagram for the benefit of the viewers. The turned form will look like this, so a parallel diameter, 3 large grooves to weaken the structure such that it's easier for the clamping screws to do their job. Chamfers all over, 45mm OD. And then at the milling machine I will slit it and put in 4 counterbores and tapped holes in appropriate locations for the cap heads, which will provide the clamping element of this. Now, in today's example, I'll not be using any coolant. This is actually the first proper run of this machine since I built it, or rebuilt it, overhauled it, and I want to see exactly what's going on. So no coolant today, but I have found this piece in the scrap bin, piece of mild steel, and I'll see what I can make out of it. Classic example there of how the heavier cut produced the better surface finish, which is quite typical with sintered inserts. The extra loading of the heavy cut makes everything hunker down and often does produce a better finish than a light cut. 0.25 of a mil to go. Right, now I'm going to pick up on this face and I'm going to try and do it somewhere near the edge such that when I touch on and leave a vague witness line, it will end up being lost in the chamfer. I think we'll actually just drop down to 490 for this. Big wide insert. Right, to my eye it has just drifted, is in the saddle position has drifted, so I'm going to try this again but with the saddle locked. That's a bit more like it. a bit of chatter there, in case you hadn't heard. What I'm going to do is the Joe Pajinski trick. I've taken this out of gear and I'm now going to run it round until I clean the chatter out, and then all I'm going to do is drop the spindle speed a bit more and have another go. Right, see if it's happy on the complete groove as we move down here. Right, this grooving tool in my opinion has made a total mess, or perhaps I should phrase that as my use of it has. You could see, aside from the chatter, that the presentation angle wasn't correct. It was making contact on this side before the full width came in. The bottom is not at all flat, and that's down to the tip geometry. I think this is designed for plunging in and then finishing sideways, etc. Now, and also of course where I didn't have the saddle locked, this wall was deformed. Now, for these cutout grooves I could leave it as it is, but I have decided not to. I'm going to sort it out with a parting tool. I've already done the first two grooves and I'll do this third one on camera, so this is just a cosmetic and geometry cleanup operation. Still only as far as aesthetics go, because of course the end of the parting tool isn't the best thing for producing a nice geometry anyway, but here goes. No harm, by the way, in doing a side-to-side move with a parting tool like that down in there, but I've had enough chatter experiences for one day, so I'm going to proceed at that. At least now they look like grooves. It is 2 roughing cuts and 1 spring cut, and my surface finish detector says it's looking pretty good. Let's see how it measures. We are now in inches, by the way, and at the mouth of the bore we are at 973, and further on up we're at 974. So we're looking at about 26 thou to come out. Okay, bore finished, and I'm now using the cheats method of chamfering the internal corner. I have just swung the boring bar around, and I'm going to plunge in. The slightly more refined way of doing it is to tip the top slide through to 45 degrees and then feed across the angle. Typically gives you a better surface finish doing it that way. Right, I shall now spin it round, face it off and chamfer it. Well, that was not my smoothest turning demonstration. It was very much real life, but more than one thing there didn't quite play out. I thought at the time it was perhaps down to my getting used to operating that machine for the first time, but when I finished the pass-off operation and I took the work holding piece out of the chuck, I spotted a clue. Now, let me show you what's going on here. This is very parallel, by the way, to a very parallel diameter. However, look at the jaw marks. 1, 2, 3. The chuck was holding that like this, bearing down on the back end. What might that be a clue towards? Well, have a look at this clip. Watch the centre pip of the faced off surface very closely whilst the roughing cup engages. You can clearly see there that the part was allowed to move within the jaws. Now, in addition to that, I mentioned at one point that I thought the saddle had moved, so I locked it. It is good practice to lock the saddle, but actually I don't think the saddle did move. What I think happened is the workpiece actually pulled itself out of the chuck. Why do I think that? Well, have another look at this clip. Based on my digital readout numbers, that should have taken an even amount off both sides, but you can quite clearly see it took an awful lot more off the back side, and that is congruous with what would have happened had the workpiece moved forward in the chuck. So I think, although there was quite a range of different bits going on there, I think it was all the cause of one error, and that was the workpiece moving within the chuck jaws, both this way, allowing it to set up a vibration and produce chatter, and also the moving out, which I had interpreted as the saddle moving at the time. Happily though, the bore was the only crucial dimension there, and that came out fine. Had the wall positions mattered, I would have scrapped the component quite early on, although had they mattered I might have actually been taking measurements and I might have found something was untoward. Now, if you are a beginner to machining, this has actually been quite a good example of how sometimes you can have lots of unrelated errors, seemingly unrelated errors, that all actually come back to one thing, which was in this case work holding. Now, also, if you're a beginner, take note of the things I did right and wrong there. I could probably have stopped earlier and done more investigations and found out what was happening, but one thing that might have gone well there was the counteraction of the chatter. The worst thing you can do with chatter is just keep plunging in and trying to cut it. All you get is more chatter. You've got to stop, take the chatter out and change something, which I picked the spindle speed there, reduce the spindle speed. So with all that said, let's do some milling. Here at the Deckel FP1 I am going to put in 1, 2, 3, 4 tapped holes with counterbore, and I am then going to slit it to allow it to clamp. Now a common approach to this may be to hold it something like this, put in 1, 2, 3, 4 holes and then come in with a vertically mounted arbor and slit it like that. Now first of all, on this machine I don't actually have any arbors suitable for holding that. I could make one of course, but I don't happen to have any, and also the vice jaws are slightly compromised here. To hold this firmly here you may require some kind of stud work or packing on this side to counteract the forces. Now what I'm actually going to do is I'm going to hold this somewhere like here, so a much better hold, and I'm then going to turn the vice to 90 degrees and I'm going to tackle this horizontally, drilling in from this angle, and then holding the slitting saw in a proper horizontal arbor, I will then slit it this way on. Now while I conduct these drilling operations I'm going to park it up at the back. Once I've finished drilling I'll bring this forward, mount the end support and slit the slit. The overarm has been pulled forwards, the end supports in position and the arbor is built up with a slitting saw. Slitting done, and I decided that seeing as I have to put the vertical head back on anyway, and seeing as I still have the part in the vise, that what I would do is leave it all set up and come in with a little end mill and sort this funniness out where the holes are broken through. So I'm going to do that off camera and we will reconvene with a finished article. My vision takes form. In case any of the milling was not clear, it was a slot drill first, in and out to create the recess, then a 90-degree spot drill put into a depth to leave me a chamfer, a clearance drill up to the slit for the bolt pass through, and then obviously the tapping drill all the way out. I was going to tap it in the setup, but as it transpired my metric taps are too fat to fit down the clearance hole, so I had to tap them at the bench from the other end. Apart from that, all good. Back where we started, and the idea is that this goes on here and then this goes in here, and then these clamp. Seems to have got it. The proof will be in the pudding when I come to cut some threads, but for now I consider this a success. The end of another machining video. I do have a plan to sort that 3-jaw chuck out, and it involves more than just grinding the jaws, so that will come at some point. Apart from that, all I have to say is thank you for watching. I hope you found this interesting, and see you on the next video.